Our dear viewers on this YouTube channel, I want to welcome you back once again in our chemistry lessons. My name is Shaka Enoch, a student of Senior 4, and I'm here to discuss with you structures and bonds, a topic from Senior 3. These are the subtopics we are going to talk about. One, definition of bonding, then why atoms of elements bond, then types of bonds, and how the type of bonds affects the physical properties of the compound formed. One, we need to understand what bonding is, and we are saying bonding refers to the attraction between atoms that hold them together in a chemical substance. So when atoms of elements combine together, there is that force of attraction that is holding the atoms together, and that is what we call now the bonding. That's what we call the bonding. There are different types of bonding, as we are going to look at in our next part. And one, we want to understand why these atoms bond together. We have to know that atoms, basically, sometimes they have what we call an unstable electronic configuration. For example, if we look at the electronic configuration of calcium, which is 2 to 8 to 8 to 2, having 2 as the valence electrons in the last energy level. Therefore, it is unstable, because for an energy level to be full, it has to be having a maximum of 8 electrons. So these elements combine so that they can now have a stable configuration of 8. There are different atoms of same elements can combine so that they can now form what we call the diatomic molecules, or atoms of different elements can also combine so that we have what we call a molecule. Here, now let us talk about now the types of bonds. One, we have the ionic bond or electrovalent bond. This type of bond takes place between a metal and a non-metal element. Then we have the covalent bond or the molecular bond, which takes place between atoms of non-metallic elements. Then we have the metallic bond, which takes place within a metal. Let us look at each type of bond separately. Let us start with the ionic bond. Ionic bond takes place between a metal and a non-metal, as we have heard. Here, there is transfer of electrons from atom to another, resulting into positively and negatively charged ions that attract each other. So, as we heard that for a bond to take place, one, there should either be sharing of electrons, or there should be transfer of electrons from an atom to another. For the ionic bond to take place, there should be a transfer of electrons from one atom to another. It means the metallic element is donating an atom to the non-metallic element, and the non-metallic element is receiving the electron. Now, let us look at, for example, how a calcium atom bonds with an oxygen atom to form calcium oxide. One, calcium is a metal and oxygen is a non-metal. When we look at here, we see that calcium, in its last energy level, or in its last shell, it has 2 electrons, whereas oxygen has 6 electrons. So both of the elements are unstable. Then they have to call during a chemical reaction, they bond together. What happens? We know that when metals are reacting with other elements, they lose electrons because they have less than 4 electrons in their last energy shell. Therefore, a calcium atom will donate 2 electrons to the oxygen atom. As you can see here, these arrows are showing an electron transfer. This electron is going to come and be donated to the oxygen atom. Then this other second electron will also be donated to the oxygen atom, so leaving a calcium atom. At first, it was having an electronic configuration of 2 to 8 to 8 to 2. When it donates these electrons, now forming a calcium ion, we get 2 to 8 to 8. And now it has obtained a stable electronic configuration. Whereas this other element, oxygen before reacting, it was having an electronic configuration of 2 to 6. Now, when given 2 electrons, it now becomes an oxygen ion. So we can have now 2 minus, 2 negative, and we'll be now having a 2 to 8, and will also be stable, and that's why this bond. So now we can see that after reacting or bonding, we have a calcium ion which is positively charged and an oxygen ion which is negatively charged. So now there is what is now holding these 2 elements together. It's what we call the forces of attraction, and they are known as the electrostatic forces of attraction between these elements, and that is what makes up their bond. So we can see we have a calcium ion and an oxygen ion, and that is what we call the ionic bonding. It can also take place between sodium and chlorine to form sodium chloride, and also other metal and non-metal elements. And gentlemen, that was the ionic bonding. Now let us look at the covalent bond. Now, this type of bond takes place between non-metallic elements. When we talk of non-metallic elements, for example, nitrogen, oxygen, a chloride molecule, and so on. So now, when we have non-metallic elements of the same substance, for example, a nitrogen molecule, it is formed by nitrogen combining with a nitrogen, so that we have what we call a diatomic. So, or if the elements combining are not of the same substance, we can also have a molecular compound. So here, how does a covalent bond take place? A covalent bond takes place when there is mutual sharing of electron pairs between atoms, resulting into a molecular compound. Now we looked at that when elements don't have a stable configuration, they always combine with each other so that they can now become stable. Now, we look at a scenario where now in ionic bonding, there was now transfer of electrons. But now in covalent, we are not transferring electrons. We are actually sharing electrons. So it means one atom will contribute an electron, and another one will also contribute an electron, so we can have what we call an electron pair. For example, we have how 2 chlorine atoms combine to form a chlorine molecule. You know that chlorine is diatomic. For example, with a molecular formula Cl2. So how is it formed? We have a chlorine atom with an electronic configuration of 2 to 8 to 6. No, to 7. Then this is also 2 to 8 to 7. These are the 7 is those are the valence electrons. So it means it lacks one more electron to become stable. And you can see that we have an unpaired electron. These ones are paired, but we have an unpaired electron even here. So what is going to happen? These electrons are going to come together, they combine so that this one gives an electron to this, and also this gives to this, so they can now share together the electron, resulting into such a thing. So we can see this electron combined with this to form an electron pair, which is now being shared by these 2 chlorine atoms, so that we can now have a chlorine molecule, Cl2, with a stable electronic configuration, since we have added a 1 electron. So we can also look at a scenario where 2 atoms of different substances are combining. For example, how hydrogen combines with chlorine to form hydrogen chloride. This is the thing. We have hydrogen, which has only 1 electron in its outermost shell, and also we have chlorine with 7 electrons in its outermost shell, but there is 1 which is unpaired, and also hydrogen has 1 which is unpaired. So since hydrogen, this is its first shell, it means it only needs 1 more electron so that it becomes stable. Remember, the first shell is filled by only 2 electrons, which is the case for hydrogen. So hydrogen will combine with chlorine, and they are going to share electrons so that they can now have a pair. And this pair will now make hydrogen electronically stable, and also making chlorine electronically stable. So that here we had electronic configuration of hydrogen, which was 1, and also here electronic configuration of chlorine, which was 2 to 8 to 7. But now when they combine, we have now electronic configuration of a hydrogen ion, which is now 2. Then we also have the electronic configuration of the chlorine, which now becomes 2 to 8 to 8. Therefore, it is now electronically stable, and that is what we call a covalent bond. Once again, our dear viewers, we've talked about the ionic bond, the covalent bond, and now let us go to the third and the last type of bond, which is called the metallic bond. So what happens in the metallic bond? This type of bond takes place in metals, alloys, and metalloids. Here, electrons are delocalized and shared among a lattice of positive metal ions. Now, ladies and gentlemen, this type of bond takes place in a metal. For example, iron, aluminium, and sodium, and many other more metals. Now, what happens? In the metals, there's what we call the delocalized electrons. What I mean by delocalized, that they are freely moving. So these freely moving electrons are shared among the metallic structure, and they are now attracted to what we call the metal ions or the cations. So when the electrons are negatively charged, so when they are negatively charged, there's what we call now the other opposite charge, which is the positive charges, which are the cations. So these, when you look at this structure, the metallic structure, these are the cations, the metallic ions, and these are the electrons. So now these electrons, they are freely moving. They are delocalized. They don't have a specific place where they're just moving around the metallic structure. So what I mean, they are being attracted to these metal ions, which are positively charged. Forming, when they are now attracted, they form what we call now a strong bond, which is formed from the electrostatic forces of attraction, forming a very hard and strong metallic structure, as you can see. So this is now the type of bonding, which is metallic bond, and formed as a result of the strong electrostatic forces between the cations and the delocalized electrons within the metal lattice. These small dashes you're seeing between the electrons and the cations or the metallic ions, it is called the electrostatic force of attraction. As you can see here, we've indicated that these forces holding the ions together is called what we call the electrostatic force, then the metal ion, and then the electrons, which are delocalized. Examples of elements with such a type of bond, we have an iron, we have sodium, aluminium, copper, calcium, potassium, and so many other more metals. So ladies and gentlemen, we've looked at the different types of bonds. Now I want to look at our last subtopic, how the type of bond determines the physical properties of the compound formed. So when substances bond with each other, their physical properties are affected, because when electrons are transferred, or when electrons, their electronic number is interfered with, the physical properties of an element changes. For example, the physical properties we are talking about is the solubility of a substance, the melting or boiling points, the conductivity, the state at room temperature, and the appearance. So we shall look at the property and each bond, how it is affected. For example, ionic bond. When we look at ionic bond, or the property of solubility, elements from substances which are having ionic bond, they are always soluble in polar solvents and insoluble in non-polar solvents. So when I say that polar solvents, I mean water. So it means ionic bond, for example, sodium chloride is soluble in water and insoluble in non-polar solvents. Non-polar solvents are organic substances, for example, methane. So if you get sodium chloride, which is having an ionic bond, it cannot be, it is not soluble in non-polar solvents, like a solvent of methane. Then when we talk about the covalent bond, the covalent bonds are soluble in non-polar solvents and insoluble in polar solvents. So it means that they are soluble in organic substances and insoluble in water. Then when we talk of the now substances with metallic bonds. For example, iron, aluminium, for them they are insoluble, whether in polar or non-polar solvents. Let us go to the second property, melting and boiling points. When we have ionic bonds, substances from ionic bonds, they have a very high melting and boiling points. This is because they have very, very strong electrolytic forces between them, and when you're boiling them, or they need a lot of heat to break the forces holding them together. That's making them have a high melting and boiling point. Then when you look at the covalent bond, it has low melting and boiling points. This is because the forces of attraction between them are weak, and therefore they can now have so we have the covalent bond. The covalent bonds, they have a low melting and boiling point. This is because they have very weak intermolecular forces between them, which means that they just require less heat or energy to break the molecular forces holding them. Thus, they have a low melting or boiling point. Then the metallic bonds, they have very high melting and boiling points, because previously we have seen that metallic bonds have strong forces of electrostatic attraction. Then let us look at conductivity. When we say conductivity, it means can it conduct, we talk of electrical conductivity and thermal conductivity. So ionic bonds, for example, sodium chloride, it conducts electricity in molten state or when dissolved in water. Then covalent bonds, they are poor conductors of electricity. So in talk of now the covalent bonds, for example, a nitrogen molecule, it cannot conduct electricity. Then we have metallic bonds. The metallic bonds, elements from substances from having metallic bonds, they are excellent electrical and thermal conductors. It means they can easily conduct electricity and heat. Then let us look at another property, which is state at room temperature. This means that when now these substances are now having a temperature which is at room temperature. That is, when we have now ionic bond. Ionic bonds, for example, sodium chloride, it will be now in a solid state when it is at room temperature. Then the covalent bonds, for example, the nitrogen molecule, it will be in a gaseous form, and for it, the covalent bonds, they can vary depending on the substance. It can be a solid, it can be a liquid, or it can be a gas. A liquid, for example, water, H2O, it is a liquid in room temperature, and nitrogen molecules or chlorine, they are gas at room temperature. Then we have metallic bonds. For them, they are solids at room temperature. For example, iron or aluminium. We have appearance. How do substances having different bonds appear? For example, ionic bonds. Substances made from ionic bonds, they are crystalline in nature. For example, sodium chloride, it appear in crystals, like our salt we use at home, or table salt. It appear in crystals. Then covalent bonds, it can also appear in different states. For example, gas, liquid, or solid. For example, liquid water, solid gas, nitrogen, and also other solid compounds. Then metallic bonds, how do they appear? We have either metallic elements or substances from metallic bonds are mostly shiny. They are malleable. It means they can be hammered to form other substances without breaking. They are ductile. It means they can be shaped into thin wires, and they are sonorous. It means they can produce sound when hit. Ladies and gentlemen, that's all I had for today. That was the bonding, the atoms, why atoms bond, the types of bonds, and how the type of bond determines the properties of an element. That's all we have for today. Ladies and gentlemen, let us remember to subscribe to our YouTube channel, Science Bro, and continue to follow for more updates and learning. Thank you so much.